All right, we're gonna try number 4 again. I did some soul searching and realized that I made a typo. So I did number 4. So it was 1 over the square root of t plus 4, and then y was, I wrote it was 1 over t plus 4, but it says t over t plus 4. So if we're trying to convert this to a rectangular set of equations, you know, we're looking at which one's going to be easier to solve. This one has double t's, so like when I multiply both sides by the t plus 4, that's going to be kind of challenging to isolate. It's not impossible. Yeah, it's not worth it. Okay, because this one's super simple. Multiply both sides by the square root, and then divide both sides by x, or just flip both sides, because that's what that does. Now square both sides. 1 over x squared is equal to t plus 4. So 1 over x squared. Now I'm going to have the solution guide open right now because I made some silly mistakes earlier. Okay, 1 over x squared minus 4 is equal to t. So then I can go into this. Oh, good. That's nice and relaxing, right? Y is equal to 1 over x squared minus 4 over 1 over x squared minus 4 with a plus 4 after it. Hey, cool. The minus 4 and the plus 4 cancel. And then this is this divided by the denominator, right? So you can keep, change, flip. So then we can distribute, this is just times now. So it's 1 over x squared minus 4 times x squared. So distribute the x squared and you get 1 minus 4x squared. So y is equal to 1 minus 4x squared. So in this situation, the function notation is so much nicer than the parametric notation. We are going to get into things, though, where there is no function notation to represent it as a single function, but there is if we use parametrics. I guess we should do one more. This is a classic. X is equal to 5 sine theta. And y is equal to 4 cosine theta. So we need to solve one of these for theta. So like x over 5 is equal to sine theta. That means I'm going to have to do like inverse sine of x over 5 is equal to theta. And then we're going to have to plug that in over here. And so y is going to be equal to 4 cosine inverse sine of x over 5. JK, this is ugly. There's a secret way to do these that's a little bit different, that arrives at the same ultimate solution, but it looks different than this and it's a little bit nicer. And that is with our good old friend Pythagoras. X is equal to 5 sine theta. Y is equal to 4 cosine theta. So here's what you really do. Solve this, get sine by itself. So sine is equal to x over 5. Get cosine by itself. What's sine squared plus cosine squared? Right? Hey, wait. Sine is x over 5, right? Cosine is y over 4. This, although you were not taught it, is the equation for something called an ellipse. And it's actually pretty simple. So x squared plus y squared is equal to 9. That's a circle with radius 3. This right here is an ellipse because the x and y are divided by different numbers. And the ellipses are always equal to 1. And so 9's the radius of this circle, right? Well, this is like your sideways radius, and this is your vertical radius. So your sideways radius is 5, and your vertical radius is 4. So if you were to go into your programs, you actually have a program called Conics. You can go into ellipse, and ew. I didn't know that they do them like this. Yeah, we're not doing that. Okay. Goodbye, Conics. Instead, we can go over, we can be in our parametric graphs. We'd say 5 sine theta, 4 cosine theta. There it is. Or, oh wait, no, we're in, we wouldn't be able to do that. So there's gonna be lots of ways that we represent functions. So I'm out of time. I'll finish up the rest later. Be right back.